Okay, time to finish up this longish tutorial. So now we're going to do it with rational equations and inequalities. So remember, rational means fraction. So we're going to be dealing with fractions of inequalities. So let's take a look at this. All right, so rational equations and inequalities. Let's look at a rational equation, and it gives you the definition here. As always, if you want to keep track of these definitions, and I recommend it, knowing the words helps you kind of paint a picture of it in your head. So if you know how to describe something, it really does help you learn it. So all of this stuff, even though it seems a little redundant, it does help out. So let's move on here. So again, and rates refers to like a ratio. So in this case, when we're talking about rate, it's the relationship between two things, how the fraction. So for example, think of slope. Slope is rise over run. So anything that involves a slope, like let's say dollars per hour, that's a rate. And it's also a ratio. So that's where fractions do come into play a lot when we're talking about money or percentages or any type of change over time. So let's take a look here. So if we're talking about this, someone's renting a truck rental, it's only $20 a day, but it's 59 cents per mile. So this is our rate right here. So if we wanted to figure out how much we were going to pay in a day's work, we kind of have to use both of these. And if we're using more than a day, then other factors come into play. But then there's another option here. We can also be charged $1.09 a mile. So up front, this looks pretty expensive. But this, if we drive too far, this might become more expensive, right? So if we're not going that far, this might be a good option. But after a while, this kind of might become cheaper just because the rate's that much smaller. So when we're doing this, we're trying to find an average cost. We take the total cost divided by the number of miles. That's how we're going to figure out which one has the cheapest cost per mile. So what we're going to do here is we're going to take this. So this is our cost per mile already. And we're going to figure out this formula. And we're going to try to figure out at what point are these equal to each other. So we're just going to set this equal to that. Our costs per the day plus our cost per mile divided by the number of miles. This tells us our average cost. This one's really easy. They just gave it to us. Then we're going to multiply both sides by x. We're going to put all x's to one side, and then we find out that at 40 miles they're equal, meaning that this one will start becoming cheaper if we go further than 40 miles. So this is a good way to kind of start comparing, but notice that we're going to involve fractions now. All right, so let's take a look at this. For a candy making competition, Tanya made 3 types of candle. Oh, is it candles or candies? Sorry. She made 3 times as many orange candies as pineapple candies. So what we're gonna do here is our orange candies. I'm gonna call it R for the R in orange is equal to 3 times P for the pineapple. So in this case, R is orange, and I probably should have used an orange pen, and P equals pineapple. So we still need to figure out what the third candy is. And then she made 30 more lemon candies than pineapple candies. So lemon candies. So lemon equals pineapple candies plus 30. So our common link here is this pineapple candy. We can write both lemons in the terms of pineapple candy. If we just take the pineapple candies plus 30 for lemons, we can take our orange candy by just figuring out what the pineapples are and multiplying it. All right. Uh, ta, ta, ta. The ratio of orange candies to lemon candies is 2 to 1. Okay, so for every 2 orange candies, there's 1 lemon candy. So, in other words, it takes 2 lemons to equal 1 orange. So now we have this really long, complicated system of equations here where they're all kind of true. Which equation could you use to find the number of pineapple candies made in the competition? All right, so we're trying to find the number of pineapple candies here. So, she made 3 kinds of candy, 3 times as many orange. Okay, we got that. So, in other words, we're trying to figure out the pineapple. Hmm. Which equation would you use to find the full number of? Okay. Which equation? So, this one, 3n. I'm not sure what this 3n is. Oh, that's pineapple. Okay. 2n, well, the n's are completely different variables here. So let's take a look here. We're trying to find ratios, so the ratios are that. So we're trying to figure out p by eliminating all of these. So what we can do here is we want to write everything in terms of p. So let's kind of do this. Let's change this R into an L. So we're going to do 3P equals 2L, right? That kind of makes sense. But now what we're going to do here is we're going to get rid of this L by turning that L into this. So we're going to do 3P equals 2 times P plus 30. What we did here, let me kind of show. So what I did here was I changed this to this because they're all equal. Then from there, what I did was I took this L and replaced it with this here because they're equal. So that's why you see this right here. And that's why you're seeing this right here. Leave that on screen for a bit. All right, so from here, I'm going to erase this because I really need to solve the problem now. Setting it up was only part of the battle. And as always, guys, feel free to rewind if you need to understand how I came up with these formulas. All right, so the next thing we're going to do now is we're going to solve for p, or at least kind of start getting this a little bit solved. So let's say I wanted to get rid of this. So what I'm going to do is I'm going to divide everything by p over 30. That cancels this out. So I'm left with 3p equals 3p over p plus 30 because I divide both sides. And I get this 2. So I'm looking at this one right here. I'm pretty sure that's the one we need to start solving this. So I'm going to click this one. Yep. And all we need to do is figure out from there what we have to do. So they weren't nice enough to do all of these fractions here. So, oh, I see what they did. They did it. Oh, this is Edmentum being smart here. So what they did here was they said, hey, let's think about this. The oranges divided by the lemons is equal to 2. Well, we're going to replace the oranges with 3p. So they're going to replace that. They're going to be like, oh, this is going to be 3p. And we're going to take this here and we're going to replace it and put it over here. So they did it a nicer way. I prefer doing the algebra way, mainly because ratios seem complicated. You really have to understand how to do it. So Let me just erase everything as soon as this lets me. Why is this not letting me erase everything? Oh, see. Of course, after I push the button combination, it lets me. All right, so now we're going to do work and motion problems. So these are really popular problems. They're usually done when it's like, oh, if it takes Henry like 3 hours to finish the job and it takes Bob 5 hours to finish the job, how long will it take for them to finish the job together? And a lot of people think that because Bob's slower, it's going to slow Henry down. It actually is faster. You have to understand that because someone else is helping him, it is going to be faster. It's not like the slower person slows the other person down and they average out. So in work problems, we kind of have to figure out our formulas. So there's always going to be some type of formula. Like, for example, the distance we travel is always equal to the speed times the time. So we just have to kind of understand what we're talking about. So work is always equal to the rate of the which they're working times the time, the amount of work we're doing. As always, guys, I know I skip them for these videos, but I do really recommend watching these. Right now, I normally would. Oh, you know what? I can just mute it right now. It was really bugging me just going through these because I was like, it was talking as I was going through it. But these do really break down the concept. So don't just skip them just because you see me skipping them. There's nothing I can really add here. They're talking, so I'm not going to talk over them talking. They're going to explain all of this, the rates and everything, and it really breaks it down into nice formulas. All right, so let's get to this. Do. All right. So here's the thing. This is a continuation of what they were talking about. The rate is 1/3. So basically, he finishes. I don't. I'm assuming they're talking about in an hour. So he finishes the job in 1 hour. So how much work can he get done in an hour? A third of the job. He does a third of the work in an hour. This person does a fifth of the work in an hour. So it's funny how I just came up with different names, but it takes them 3 hours to do the job. It takes them 5 hours to do the job. So what's happening here is we're doing an unknown amount of jobs. We add them together, and that's going to give us this one, the job being complete, basically. So, so his part of the job is a third, is fifth-ish. We don't know how much time is being worked. So that's our x. The x is what we're solving for. So in order to do this, we're going to find the LCD. And we've had a few problems like this where we need to find the LCD, the LCM. And the easiest way to do that is just multiply everything together. There's an invisible one here, by the way, which is 15. All right. So that's what they're doing. They're multiplying everything by 15, just like we did in the last module. And now that simplifies this where we got rid of our fraction. So every time you want to get rid of your fraction, find the lowest common multiple and multiply everything by it. Everything will reduce, like this 3 and this 15 turn into 5, this 5 and this 15 turn into 3, and obviously the 1 and the 1 can't cancel, so it's just a 15. With the invisible one I'm speaking. Add them all up, and then we can figure out. It's going to take about an hour and 8.75. So less than 2 hours. So even though it took Rick 3 hours to do the job by himself, and Doug's a little slower, he's still able to finish the job faster because slower help is still help. It's not like Doug was super distracting people or something. Now that might be a different story. So now we're gonna do equations with time. You've probably heard jokes like this. It's like, oh, if two trains leave and blah blah blah. So this one we're doing two airplanes leave an airport at 9 a.m. One flying west, and the other one is flying east against the wind. A plane one travels that many miles in the time it takes plane two that. If not for the wind, both planes were flying at the same speed. So, in other words, we have to think about this. The first plane is traveling an unknown amount. So we don't know. We have to ask ourselves, what is the speed of the air? So, what is the speed of the planes in still air? So, how much would it be if they weren't traveling, right? Or weren't fighting against that air or getting that boost of air, tailwind versus a headwind. And a friend of mine who's a pilot taught me this. It's like a headwind means you're fighting against the wind. A tailwind means you're getting that boost from the wind. So that's how pilots calculate how they're going to fly. Okay, so how long will it take them to be that many miles apart? All right, cool. So we kind of have to think about this. We have a force, like let's say there's a wind going. So which one's going? So plane one is flying west with the wind. So the wind is going this. Let me use a different color. The wind's going this way. We don't know what the wind is. And it's slowing this plane down. So this one's flying. But this one is like going super faster. It's going a lot faster because of that wind. That wind's giving it a boost. So we're going to call this plane 1 plus the wind. And this one's going to be plane 2 minus the wind. Let's solve this problem. All right, so just to kind of paint the picture a little bit more clearly for you guys. All right, so we're talking about the distance traveled. Then we have to figure out the rate. Well, we're lucky because in this case, the rate should be the same besides that wind. So let's figure this out. All right, so we're going to go here. So one of them so the wind's 20 miles an hour. So I used a variable, but I forgot. We already knew how fast the wind was going. So this is their rate. One's with the wind, going 20 miles an hour faster. The other one's without the wind. And then the amount of time. We don't know time. We just know that it's distance divided by their rates. So think of it this way. Speed equals distance over time. Well, another way of saying this is saying time is equal to speed. Oh, I'm sorry. Distance. Distance divided by speed. That's supposed to be a t. The reason for this is you're multiplying t to both sides, and then you're dividing by s. So basically what's happening is the s and the t switch spots. All right, so now we got to figure out what these x's are. So we're going to plug it in. Give me a second here while I go back to mouse mode. We're going to make these two equal to each other. So they're supposed to have the same rate. Even though they look different, the x's should be equal to each other. So these two are the same time. It's the same time because they left at the same time. So there's no further calculation needed. So what we're going to do here, whenever you guys see a fraction divided by a fraction, you are going to cross multiply. So you're going to cross multiply these problems. And because of that, we're going to get 600 times this x minus 20, then 440 times that. Go across, and we're going to solve that. All right. So after doing all the arithmetic and everything, we find that the planes would have been going 140 miles per hour. I'm assuming we're doing it in miles per hour. How fast was the wind going? Oh, forgive me. The wind was going, we're talking about miles and both with the wind, that many miles apart. When did they? Oh, there it is, miles per hour. So we are talking about miles per hour. I was like, I know they mentioned it somewhere, otherwise that would have been very awkward. All right. So in order to answer these questions, let's see, by plugging it in, we should get them equal, and it checks out. I didn't really have a doubt in that. So let's try to do this. So we're going to figure out, we'll use the information in the table below to find out how long it will take for the airplanes to be 2,100 miles apart. Now we have their rate. Don't forget, we're adding that wind to this one and subtracting the wind from that. So that will, so 140 plus 20 is 160. And then 140 minus 20 is 120. Now the distance, it's going to be the same amount of time because again, they're still leaving at the same time. We just need to figure out the distance. So remember, if speed equals distance divided by time, then we can say then that distance equals speed times time. So that's why we're getting these together. So we need to add these distances to end up getting what we want. In this case, the 2,100 miles per hour, or 2,100 miles. Woo, that would have been way too fast. Uh, the distance. So they're adding those together, and we find that's going to take them 7.5 hours to get that far apart. So using those tables is actually really helpful to plan out your scenario. All right, so let's do our hopefully last activity. All right, so I'm going to use the highlighter tool here. I always use my own highlighter tools, but I'm going to show you guys how to start using this. So we're talking about Emma, and we're going to talk about Jackson. All right, so they're both working out, they're helping, volunteered, call every business owner in small town to request donations. Emma can complete the calls in 6 days. So Emma can complete this in 6 days. So I'm going to make it yellow for Emma when she works alone. Jackson can complete the work in 4 days. So Jackson's doing this faster. Make that purple. To complete the work, they want to work together now. So if we want to work together, Emma, so Emma, oops. Oh, I can't highlight it. Well, I'll do this. Do it in my head. There we go. And Jackson, we did was kind of a purple color, so sure. All right. So in other words, it's a fraction. The hours it takes, we don't know that. So that's a big X. This is an X too. They're working together, so these times should be the same. All right. And their rate. So in one day, how much is Emma going to do? Emma's going to complete 1/6 of the work in a day. In one day, she does 1/6 of the work. If we did 6 days, it would be the entire work. And then Jackson, it takes him a fourth. Every day he's doing a quarter of the job. So after 4 days, he does the whole job. That's one number. So when we do this, it's the rate of work times time work is how long it takes for it to be completed. So this times this equals that. So we're going to say that it takes to work completed. Hold on. Oh, there it is. I don't know why I was struggling picking that up. There we go. So we're going to get that. That should be our answers here. So again, that's their portion, their rate, how fast they're doing it. And we're going to take the total amount of time divided by 6. All right. So now, understanding the table to determine this, the calls the table created, determine how long. Okay. So we're going to use this table created. I'm going to move this up a little bit. Luckily, they give me the sample answer here. So what we're going to say here is we're going to have two fractions. We're going to have x over 6. That's how long it takes them. And we're also going to have another fraction, x over 4, and this is the amount of time it takes them to do one job, the whole job altogether, 100%. Don't think of this as a 1, think of it as 100%. Remember when we use percentages, think of them as decimals. 1 is considered 100%. So now we're going to multiply everything by the LCD. So I'm thinking 4 times 6 is 24. But hold on. I can reduce still. Because 6 over 24, I can divide that by 6 and. Or wait, I'm sorry. 6 over 4 can get 6. So they can turn into 12. Everything's divisible by 2, so let's divide everything by 2, and we end up getting this 12, right? So if you didn't understand that, you could always do this. 6 plus 6 is 12. 4 plus 4 is 8. Plus 4 again is 12. So the lowest common denominator is 12. There's also a trick with exponents, but I don't want to get into that right now. Um, I really want to, but I won't. I won't. So we're going to multiply everything by 12. So in the next step, we have these parentheses. Going to put our equation in there, and everything's getting multiplied by 12. So therefore, this 12 and the 6 cancels out with this 12, and we get a 2. So we get 2x plus the 4 and the 12 cancel, and we get a 3. And unfortunately, that 1 and 12 can't cancel, so we end up getting 12. And then we're going to end up getting 5x equals 12. So we end up getting x is equal to, give me a second here, 12 divided by 5, 2.4. So get that, submit it. So it looks like it's 2.4. Let's take a look. Yep, got it. All right. Now we're going to start solving this one. So again, it helps using the calculator. So John's flight. So here we go. Here's John. Let me get all of John in there. John's flight. So John took a flight on a plane that flies that many miles with tailwind. So again, they say it right here, tailwind increases the speed. The plane travels against the wind on the return flight home. So, okay. So, I guess that's not really going to help us out. With tailwind on the return flight home, he's fighting against the wind. So, against the wind with the same wind, but this time it really lowers his speed. Assume the airplane cruises is that much without wind. So we need to figure out what this wind is. All right, which decrease speed? Let x represent the wind. X represent the wind. All right, cool. So the rate. The rate is this, but we're gonna add or subtract the speed. So when he's going from New York, what we're doing here is, this one's simple. What's his rate? This is his rate. And then we need to figure out what the wind is. So what we're going to do here is we're going to take hold on. This is okay. We're going to do this minus so this is what it would be without the wind, but we have to subtract the wind because it's going slower. All right. And then we're going to try to figure out distance. So time. Does it say the time? It does not. But how far is it? Oh, with a tailwind. Hold on. This is distance, not speed. So There we go. And then our distance is this. Both of these travel the same distance. They're just traveling at different rates, which means different speeds. So remember, let's take a look at that formula again. Speed equals distance over time, or we can see it as time equals distance divided by speed. So we're going to be looking for 740 on the top of both of these. So we're going to be looking at these ones. And all we're going to do is boop, that goes there, this over this, and this goes here. Perfect. I never remember it as time equals work divided by rate. I always remember it as rate is equal to work divided by time. So it's interesting that they kind of teach the other way. I understand why they do it because it's still true, but it's just interesting. So there we go. Filled in the chart. So assume it takes 3 hours to fly. So now what we're going to do here, round trip. So back and forth. They're really nice. They keep giving us the definitions. The reason why they're doing this is they want us to add everything together. All right. So here's what we're going to do now. So we're going to apply what we learned in the last unit where we just multiply everything together. All right. So here's what we're going to do. We're going to set up the fractions. So we have two fractions. I was like, where's my fraction button? There it is. 740 4 plus x. I'm going to add, and I'm going to literally just take this, but I'm going to remember to change it to subtraction sign at the bottom. And then this is going to equal, it's going to equal 3 in this case. It's going to take us 3 hours. So we're adding the times together to get that 3 hours. So this one's a little different. Now, this one seems harder, but what we're going to do is it's no different than what I was saying when you multiply by 24, but then when we divide by 6, it ends up changing it. I know it sounded complicated, but basically what we're going to do is we're just going to multiply everything, pretend there's a 1 here, by 49 plus x times 495 minus x. Now, the reason why we do this is this cancels out with this, so we end up being left with, I'll write it down, I'll type it out, I mean, 740 parentheses 495 minus x plus, is there none, shoot, I got spoiled by annotate. All right, and then the next one, make it more yellow. The next one is plus. In the next one, this cancels with this, so we're gonna have the same thing, but this time there's gonna be a plus sign because the negatives canceled out on this one. Now, unfortunately for the 3, it doesn't have anything in the bottom to really cancel out with. It's just a 1. So the 3 becomes this really, really big mess. It's 3 parentheses 4, 9. I hope they don't make us like do all the arithmetic for this. I want them to just have us solve it, but let me type it all up. So that's how you do it. I'm going to read the question again. So I'm reading this question. Assume it takes approximately how long it's tailwind, though they do want us to solve this. All right. Let's take a look here. Let me see if there's anything I can do to cancel stuff out. Hmm. I'm looking, but it is not looking good for me. Time to do some distributing, it looks like. Now, the benefit that I'm seeing here, this would have been the hardest part, but this is actually dose. So remember, dose is a plus b, a minus b is equal to a squared plus b squared. The middle term ends up canceling out. All right, so what we're going to do here is we are going to grab our calculator and we're going to do 495 times 495, and we get, oof, that's a big number. All right. Um, and what sucks is a lot of this ends up canceling out, guys. So, give me a moment to kind of digest this in. And 0 to 5 minus x control up squared. Oh, and I just realized I think I did it as a squared plus b squared. It's actually supposed to be minus. Remember, the D in dose stands for difference. My bad. So if you rewind, you'll totally see that I messed that up pretty bad. The scrumming part too is, guys, is this is still not done on this side because we still have to multiply this 3 over. So there's still quite a bit of work here. Give me a second. One beauty is this 745 is going to cancel out with the x at least, because this is going to be negative 7045x. This is going to be positive 45x. And I'll do the actual work for it right now. Um, so give me a second here. Oh, no, 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 no. Keep that stuck. There we go. Okay. So, let's do this. 740 times 495. Okay. Oof. 366,300 minus 740x, because we're distributing this here. Oh, let me physically show you guys. We're distributing this here. This one, I did this times this, and I used dose just for a recap. And I'm going to distribute here as well. So, ironically, well, not ironically, there's a reason why they're the same because of the original distance. Um, they're the same, so I can still say this is plus 3, 366,300. It's going to be plus 740x. And as you can see here, like I said, this cancels out with this. So what's left here is we're going to have, I'm going to multiply this by 2 because it's the same thing. We're going to have 7,326,000 equals, because again, those x's canceled out. Let me erase everything here. I'm going to distribute that 3. So give me a second here, guys. I'm going to get 3 times 245025 is equal to, ironically, it gets really, really small, which is a good thing because that would be a really, really fast tailwind had we not gotten it a lot smaller. All right, we're going to do that. Then we're going to subtract this from both sides. So Alright, so we're going to take 732,600 minus 735,075. We end up getting a negative number, which is good because we're eventually going to have to divide this by -3, -2475 equals -3x, control up to do the squared, and we're going to divide this by -3. I'm just going to divide it by 3. Oh, you can actually do a little negative sign right here. Boom, and we get a positive 825. So I'm finally going to move this over because it's been bugging me that the x was on the right side. Is equal to 825. Let's see if this has a square root. It does not. So the tailwind is actually really small unless I did a mistake somewhere, which if I did, forgive me, but I'm pretty sure we did that step by step. Boom, submit this. Oh gosh, yep, there we go. And obviously it can't be negative, so it has to be the positive version. All right, compare the work problem you solved in this motion of this. How are these two problems alike? How are they different? Both problems involve uh, rational expressions, but they differ because one of them, let me take a look here. So we're looking at this one. One of them, what were we solving for? We were solving for one of them has us solving for a rate with a given time, while the other has us solve for the rate. And I kind of wrote those backwards. I think I wrote it backwards because the other one was fresh on my mind, and you saw I had to scroll up to do that. What's this? I understood it fine. However, it was a lot of work calculating the polynomials. We had to do so much operations there. So let me submit this. And of course, I always forget to submit these. So moving on. So let's look at our summary. All right. So again, guys, always watch your videos. I highly recommend watching the videos as well as doing the guided notes. I cannot stress to you how good the guided notes are. All right, guys. So that is the second module. And because we only got through one module this week, the Kahoot is only going to be based off this module. All right. Have a good one, guys.